Hello and welcome to Neon Math. Today, I'd like to teach how to solve systems of linear equations using the method of elimination. What is a system of linear equations? Well, here's one linear equation. And what makes it a linear equation? What makes it a linear equation is I have an x or a y or both. There are no exponents greater than 1. They're just to the first power. No squareds or cubes. I don't have any crazy radicals or square roots, cube roots. Just have normal x, normal y, one of each or both. And that will result in a line if I were to graph it. When I have an x and a y, I'm going to end up with some kind of diagonal line. If I have only an x or only a y, I'll end up with some horizontal or vertical lines. What makes it a system? I have two of them, two equations. Why would I want a system of linear equations? How is that helpful? Well, if I'm trying to solve for two variables, it's really helpful to have two equations. If I want to solve for three variables, got the elusive z in a problem, then I'd like to have three equations. But that's not what we're doing today, just two of them. Now, the method that we're using today, elimination, it works very well when we have two equations that are perfectly lined up with each other. In this case, I have my x's lined up, my y's lined on top of each other, my equal signs, and my constant, just normal numbers. They're all lined up perfectly. They don't have to be lined up in standard form like that. As long as they're all lined up perfectly, I don't care what order they're in. When we use elimination, there's a couple different ways we can go about it. We can just use addition. Remember, these are the ones where we stack them on top of each other, and then we either add them or subtract them. And how do I choose which is the best to use? I like to use addition when I have the same variable, which hopefully I'm always going to have. They each have the same coefficient. Okay, so right here I have two 2's, but one of them happens to be positive and one of them happens to be negative. So when I have opposite signs, then it's great for addition. If I had exactly the same thing that I just showed you, but these were both maybe both positive 2's, then they'd be perfectly set up for me to be able to subtract them. And why am I trying to add or subtract these things? Because I'm trying to eliminate two terms. In this case, I'm going to eliminate both of these. That's going to eliminate a variable out of this problem, just leaving me with y's, and then I can solve for y's. Other times, I'll be able to eliminate maybe the y variables, and then I'll solve for x. All right, so let's just jump in and try the problem. These ones are perfectly set up. I have a positive and I have a negative, so I'm going to use addition. And I'm just going to go start adding, just like this, watch. 2 plus a negative 2 is 0, so this is gone. I can write a 0 here, but I'm not going to. Here I have 5y's plus 3y's gives me 8y's. 25 plus a negative 1, or just 25 minus 1 is how I'm going to think of it, is 24. The opposite of multiplying by 8 is dividing by 8. And if I do it to one side of the equation, I'm going to do it to the other, leaving me with 1y equals, because 8 divided by 8 is 1. 24 divided by 8 is 3. If I'm talking too fast, down at the bottom right of your screen is a little gear. You can hit on that gear and slow me down, or you can speed me up using the speed thing. You can figure it out. Okay, if I were to graph these two equations and saw the point where they crossed, I could describe it as x comma y. That would be the solution of this system of equations. I just discovered that y equals 3, so I'm going to write that as part of my ordered pair, y equals 3. But I still do need to find x. So let's go looking for x. Well, how do I do that? What I do is, now I'm going to use a little substitution. I have another video that teaches complete substitution. You're more than welcome to check it out. I'm going to take this y equals 3 and I'm going to plug it in there or there. It's your choice. I'm choosing the top equation because it's all positives. And I'm always going to try to go the path of least resistance. And so now I'm going to take this 3 and I'm going to plug it in right there. So I'm going to rewrite this. Instead of 5 times y, I'm going to write 5 times 3. And of course, you don't have to, well, unless your teacher tells you to, you don't have to show all this work. You know 5 times 3 is 15, and you could have just written 15 up there. Okay, so let me rewrite this. 2x plus 15 equals 25. I'm going to subtract this 15 from both sides, leaving me, that's gone, with 2x equal 25 minus 15 is 10. So it multiplies 5 to both sides. Bloop, bloop. And 10 minus 2 is 5. Whoa, I just figured out what x is. That means the x and the y in these equations, x is 5 in both equations and y is 3 in both equations. That's the answer. That's the solution. But just to make sure you put a box around. You always want to put your answers so teachers can find them easy and put them in the format they ask for. All right. So if I were to graph these two, they would cross at 5, 3. Let's go run over to Desmos and I'll prove it to you. So I just graphed the first one. I'm going to graph the second one. And I'm going to see where they cross. And they cross at 5, 3. X equals 5. Y equals 3. Wow. Desmos is a powerful tool for checking your answers, isn't it? When I'm recording, I guess it won't let me do a screenshot. Outside of my screen on the left side is where I typed in all of the equations. Okay. So, on to our next problem. Let's continue solving with elimination using addition or subtraction. All right, I have a couple of new things to try. This is kind of weird. Well, okay, these aren't the same clearly. So, I do have, these are the same, and they're both positive. And I remember on the last screen, I can subtract those. When I was a youngin', we almost always used addition. So they would teach us, okay, you want to make one of these positive, one of these negative. So I would basically multiply the entire one by -1 to turn this into a -3. And then, so those would cancel. But we don't have to do that because we can just be smart and say, hey, I can subtract and 3 minus 3 is going to eliminate those terms. Now, what if these problems were given to us in slope-intercept form? Could we still do elimination? And yeah, we totally could. Everything's lined up. My y's are lined up, my equal signs, my x's, my constants, they're all lined up nice and neat. I could totally line them up. I could just go ahead and subtract these like this. My y's would cancel out. I don't like fractions, but my 2/3 minus my 1/3 would give me 1/3 x. Y minus y was 0. And my 5 minus my 2 would give me 3. And then I could continue from there and subtract the 3 to the other side. And then multiply by the reciprocal of 1/3. And I'd get an answer. I could totally do that. Just so you know. Okay? Don't think it always has to be in standard form for this to work. But here we are in standard form. -2. Okay, so I have -2 minus 1 gives me -3x. 3 minus 3y is 0. And 15 minus 6 gives me 9. Now, the opposite of dividing, or multiplying is dividing. I'm going to do it to both sides. Okay. So, that point xy, I found my x. Now I got to go find my y. Again, I'm going to take it and I'm going to go plug it in. I think I'll plug it in right there. Ignore that minus, that negative right there. That was my minus sign. This was a positive x when I started the problem. So I'm going to go ahead, x plus 3y equals 6. I'm going to go ahead and plug this in here. I'm going to add it to both sides. and 3y equals 9. And I'm going to divide 3 to both sides. And 9 divided by 3 is 3. And if I did this right, x equals negative 3, y equals 3. And this is the point where they should cross. I'm going to go run over to Desmos and find out, did I get it right? So I'm going to graph the first one. I just type it in using x's and y. And I type in the second one, see where they cross, and negative 3 comma 3. I did it. I got them right. That's how I check my answer. All right. Let's go again. Solving using the elimination method. Ooh, this one looks a little bit crazy, and it is not lined up at all. My x's and y's aren't lined up. My equal signs aren't lined up, so I have a little bit of work to do. I'm comfortable with this one in standard form, so I'm going to leave it alone, but this one I have to manipulate. And really all I have to do is just add this 3x to move the whole term to the front where I'm comfortable with it. And this will become, gotta be careful, add it to 3x, Then I have this here. Oof. These are not the same. Can I turn a 3 into a 5? No. Can I turn a 5 into a 3? No. I could multiply them both. I could multiply 3 by 5 and turn it to 15, and 5 by 3 and turn it into 15. That seems like a lot of work. But here, I can turn a 2 into a 4 pretty simply, right? I can do that. So I could turn, I can turn a 2 into a 4. One happens to be positive, one happens to be negative, so that's nice. So I'm going to go ahead and multiply this whole top by 2. Because I can't just run in here and just multiply this by 2 to turn it to a negative 4. That's cheating. I have to multiply the whole thing. And I'm not changing the value of that equation. If I graphed it, it'd turn out the same. 2 times 3 is 6x. 2 times negative 2 is negative 4. 2 times 2 is 4. And I'm going to rewrite the second one that I didn't touch. Now I'm going to stack them. I'm going to add them. And I have 6 plus a negative 5. 6 minus 5 is just 1x. Positive 4 and negative 4 added together, cancel. And negative 6 plus 4, opposite sign. So I'm really in my head, I'm going 6 minus 4 is 2. 6 is bigger than 4, so negative wins. And I have my x equals negative 2. Very nice. Now, to finish this problem, I just have to take negative 2 and go plug it in here or or I even could, I could even plug it into my newfangled one here. I like to go back to the source in case I messed something up, even though I'm going to be wrong anyways. But still, I like to go back to the source, to my original equations. And I think I'm going to use the second one. So I'm going to go negative 5 times x. But instead of x, I'm going to put in my negative 2 plus 4y is negative 6. A negative 5 times a negative 2 is positive 10. Subtract my 10 to both sides. These problems are long, aren't they? And a negative 6 and a negative 10. If I owed $6 and then I owed $10 more, now I owe $16. Same sign, you just add and keep the sign. I'm going to divide by 4 to both sides. And I am left with negative 16 divided by 4 is negative 4. If I were to graph these two equations, where would they cross? Let's go to Desmos and find out. There they cross right there. And at negative 2, comma negative 4. Very, very nice. I got my answer right. Okay, Now it's your turn to practice. Try out these two problems. These are pretty straightforward. You can use addition on one of them. You can use subtraction on the other one. Or with the second one, if you were to multiply top or bottom by -1 to turn one of these to a -2, then you could use addition. But I'm going to let you determine how you go about solving these. All right, how'd you do? I'm going to go through these really quick to check our answers. In this first one, I have, let me change my color. In the first one, I have a +3 and a -3, x, everything's lined up, everything's perfect, ready to go. So I know exactly what I'm going to do. I am going to just stack them. I'm going to add them. 3 plus a -3, it's going to be gone. 15 plus 7 is going to give me 22y. And 24 plus -2 is going to give me 22. I'm going to divide 22 to both sides. And I'm going to get 20. Anything divided by itself except 0 is 1. Okay, I got my y. I'm going to take that y and I'm going to plug it in either here or here. I'm going to do the top one. 3x plus 7 times, instead of y, I'm going to put 1. And this gives me 3x plus 7 equals -2. I'm going to subtract the 7 to both sides. And it's going to be, where should I write it? I'm going to write it over here. Sorry, messy paper. A -2 and a -7 gives me a -9. Divide 3 to both sides. And -9 divided by -3 equals -3. I hope that's right. We'll go check it in a minute. All right, let's come over here. Like I said, you could multiply the entire top by -1, so we could turn this to a -2, and then these two would cancel when we do addition. Or just go ahead and subtract. 4 minus 3x is 1x. 2y minus 2y is gone. 8 minus 6 is 2. Doing pretty good, huh? Now I'm just going to take that 2 and I'm going to plug it into that. I think I'll use the bottom one this time. Remember, this minus here it's not saying it was a -3. It was us subtracting our problems together. Be careful. You don't have color coded when you're using pencil. 3 times, well, some of you do. Use colored pencils for math. They don't erase too well, do they? I'm plugging that x in there. Okay, 6 plus 2y equals 6. Or if you have one of those little fancy clicker pens with the 4 different colors. If you're really confident and do your math in ink, that's next level right there. 6 minus 6 is 0. We divide 2 to both sides, and y equals 0. Okay, I need to run and check my answers. The first one we're going to check is, did these cross at -3, 1? And there they are right there at -3, 1. Nice. And the second two, where did they cross? Oh, they crossed on the x-axis at 2, 0. And did we have 2, 0? Oh, yes, we did. We did great today, didn't we? It was just a lot of hard work, and you did very good. If you want to see how to do substitution, you can check out my other video. It's a little longer, and there's a quote-unquote real-world problem in it. Anyways, have a wonderful, wonderful month.